All right, so chapter one. This is raise points, lines, planes. So this is like the foundation.
Nerd.
I apologize about her. That is my sister.
No apologies, nerd. Just pay attention to your Bob Ross poster now. Stop being such a nerd.
I'm gonna have to cut this out. But this is like the foundation of all shapes in geometry, and that's what geometry is all about, right? So let's start, and this will be more of review, if anything, but let's start with a single point. So a single point is just represented by a dot, and we label it with an uppercase letter. A point has no size, right? So it's just pinpointing a spot in space, but it's not actually there, but it is. I mean, it's kind of weird, but that's a point. Then a segment is going to connect 2 points, right? So if we have a point and then we have a segment is made up of infinitely many points in a line like this, and it connects 2 points. This will have no thickness because it's made up of something that has no size. If you were writing, you would write this segment as like this. AB with a line over it. I should probably write that bigger. A, B with a line over top. Just like that. That's how you draw a line segment. Oh, sorry about that. Next, moving on to rays. A ray has a starting point, but it has no ending point, so it just goes on forever. So, like this. And then this again has no thickness because it's made up of infinitely many points. And this is denoted as ray AB. So you write AB, and then you draw just a ray over top of it, like that. And then finally, well, not finally, but finally for the one-dimensional is a line. So a line is labeled with 2 points like this, and it goes on forever in either direction. And again, it has no thickness because it's made up of infinitely many points, which have no size. It does not have a beginning or an end either because it goes on forever in either direction. After that, so you've heard of all of this before. That's why I went over it pretty quickly. But now, if we move into the two-dimensional with a plane. So a plane could draw as something like this, right? L-A-I-N. A plane would look something like this, and it extends in all directions forever, like infinitely in every direction. And it's going to have an X and Y axis, like that. But how would you label, well, actually no, let's move on from a plane. We'll come back to that in just a second. But let's talk about, first, collinear and non-collinear points. So if we have any 3 points, we'll label it point A, point B, and point C, like this. And if I can connect these 3 points with a single line that goes straight, like that, these points are collinear. They are on the same line, right? So if you think of something like f of x equals x squared, well, or not f of x equals x squared, just f of x equals x. That is a line, that's a linear equation, and all of the points on that, because it's made up of infinitely many points, all of the points on that will be collinear. But what would non-collinear be? I'm sure you figured it out by now, but if we have here, we'll call this point A, point B, and point C, like this, and I can connect point A and point B with a line. So point A and point B are collinear, but I can't fit C on that line. Same with A and C, so those are collinear, and again, B and C. So A and C and A and B are collinear, but A, B, C are not collinear because I can't put them on one line. Now, if I make this line curve, I could do it, but you can't curve lines. Right, so points A, B, and C would be non-collinear. From there, going back to planes, if collinear meant all on the same line, coplanar would mean all on the same plane. Right, so if we had a plane here, like this, and we had points A, point B, and point C, while point A, point B, and point C may not be collinear, they are coplanar because they're all on the same plane. But an example of non-coplanar points would be something like this, where if we take this two-dimensional plane and we bring it into three-dimensional space, right? So if we have point B is sitting down here below the plane, whereas point A and point C are on the plane, point A and C are going to be coplanar, but points A, B, and C are non-coplanar because they're not on the same plane. B is below it. So again, you kind of have to think outside the box for this, where you have to take something that is strictly two-dimensional and rip it and bring it into three-dimensional space for this to work, which was kind of mind-bending for me at first to comprehend putting a two-dimensional into a three-dimensional space, but I mean that's how you would teach this. Now back to that question I proposed earlier. How do you label a plane? So now that we know collinear and coplanar, we can take our plane here and say we label it with 3 points on 3 coplanar points that are non-collinear. So non-collinear, but they have to be coplanar. So like point A, B, and C would not work because these are collinear. While they're also coplanar, they are collinear, so we wouldn't know whether you're describing the plane or the line, right? So we would have to have something like point A, point B, and point C. Like this, where these are non-collinear, but they are coplanar. So I can just write this as the 3 points. So you could do, A, B, C, C, B, A, B, A, C, anything like that. I'm not going to go through all the examples. You just label the 3 points if you want to talk about a plane. Next, I have some practice problems for you. So if we have this plane here, like this, and I have the points A, B, C, D, and F, with the point E being underneath the plane after we rip it out and put it in 3-dimensional space. And again, really to drive this home, if this is our plane here, the Monty Python to Spam mousepad, I know, my sister's right, I am a nerd, but if we have all our points sitting on this mousepad, then those would be coplanar. But if we have a point sitting here, or a point here, here, something like that, that's how you would get it to be non-coplanar, right? So from here, my question is, what points here are coplanar? Think about it. All right. So points A, C, D, B, F are coplanar because they're all on the same plane. Point E is going to be underneath the plane. So then find for me any pair of collinear and coplanar points. So if you think about it, choose any pair. Okay. So this could be AC, AD, AB, AF, really anything except for or anything that doesn't use E in it, because again, that would be drawing a line through 3-dimensional space. If we had a point here and a point here, that would be drawing a line like this, and that would not be coplanar because it would cut through the plane, but it wouldn't be on the plane. All right. Let me get next problem here for you. So if we have a circle, this is our plane, right? We have C, B, D, and A, like this. So find for me 3 collinear points. Think about it. All right, segment. If we drew a segment, it would be CBD. You could connect with one line. Because A, you can draw a line from C to A, B to A, and D to A, but you couldn't go to any of the other points. Then give for me any 3 points that are non-collinear. Think about it. All right, so this would be ACB, ACD, really anything with A and 2 other points would be non-collinear. All right, now a couple more questions. Don't use a diagram, just oral. So what makes up a point? What does a point contain? What makes up a point? Got it? All right, nothing. This was a trick question. Nothing makes up a point. It has no size. Okay. What makes up a line? If you think about it, what makes up a line? Infinitely many points. So a line is made up of infinitely many points. And finally, before chapter 2, what makes up a plane? So what makes up a plane? So a plane is made up of infinitely many lines, right? And I can't remember if I said that earlier. That was my mistake. If not, I'm glad I'm getting to it now. But a plane is made up of infinitely many lines. So it kind of stacks from point to line, line to plane. All right, that's all I have for chapter 1. Chapter 2, let's see, what do we get into in chapter 2? Ooh, statement reason. All right. 2 table proofs.